So this is the last lecture in the Toolbox Basics course, and here I want to give a brief introduction to the command line tools. Now the command line tools are well documented in chapter 7 of the handbook, so I don't want to go into too much detail here. I just want to describe the three main command line tools that you can use for running the simulators in batch mode, so that's without the graphical user interface, and doing this in your own scripts. Now the principal command line tool is bdSolve. It takes as input a system structure and it runs the simulator to integrate that system forward in time, and it returns the solution in this MATLAB solve structure. Now the solve structure is exactly the same solve structure that is returned by the MATLAB solvers such as bdE45. And in that structure you will find the time steps in the X field and the state variables for those matching time steps in the Y field. So let me just show you how that works. So I'm going to construct let's use the Wilson-Cowan model like we did in the last lecture and run that. I'm going to define the time span that I wish to run my simulation. This is an optional parameter that you can pass to bdSolve. So let's simulate from 0 to 300 milliseconds, and now I'll call bdSolve, pass that system structure sys and that time span to the solver. Okay, so here's our solution. The time steps are in X and the state variables are in Y. So we can now plot that if we like. We can plot sol.x, our time steps, and sol.y, our computed trajectory. And there it is. So one row in Y. So Y is a two-row matrix. And the first row contains the E values from that Wilson-Cowan model, and the second row contains the I values. So we can just put a legend on our plot so we can tell which is which. So the E is the blue and the red is the I, the inhibitory population. Now the solution returned by the solver is, you will remember, in variable time steps, and I can plot those time steps here just by changing my plot function a little bit. So here we can see the variable time steps returned by the solver. Now often you want those solutions in fixed time steps, and so this is where we run the interpolator. Now the interpolator is embedded in bdEval. So this is the second command line tool that you need to know about. So bdEval takes the incoming solution and another variable x in, which is the time steps that you wish to evaluate the solution at, and it returns the solution in Y. It returns the interpolated solution in Y as well as the time derivatives in YP. So let's define a time domain of interest. Let's say we want to go from 0 to 300, and I want to go in steps of 5 milliseconds just so I can see the fixed steps in action. Okay, now we apply the interpolator. Y equals bdEval. The first input is our solution, the second input is our time domain. Run that, and I can see that Y is a two-row matrix with 61 time points, so I can plot that. Plot t domain versus y, and I'll include the markers to show the individual time points. And there we have our solution interpolated onto fixed time steps. So that's the basics of running the command line tools to simulate your models in batch mode in your own scripts. bdEvolve is similar to bdSolve, except it returns a new system structure where the initial conditions have been updated. So that's exactly the same as using that evolve checkbox in the graphical user interface. So with these three command line tools I've just described, I just want you to have some confidence that you're not stuck with just using the graphical user interface. When you advance your project, you can switch from the interactive mode into the fully automated mode using your own batch scripts. And so that ties back to the project lifecycle that I described in the first lecture. So with that, we now come to the end of the Toolbox Basics course. I really hope that you have found this useful in getting up and running quickly, and I hope you enjoy using the Toolbox. Now, if you want to take it any further and get into programming your own custom models, I recommend you take a look at the Modelers Workshop. That's an 8-hour course where we look into programming your own custom models. So that's it from me here in Sydney, Australia, still in COVID lockdown.